Okay, hello Cloud Gurus and welcome to the application section of the course. We're going to start this section by talking about SQS. Now, if you remember back from section 2 where we talked about a history of AWS, SQS was actually the very first service that AWS released. It was even older than EC2. Now, because of this, it has been around the longest and it does feature quite heavily in the exam. So you really do need to know what SQS is, what it does, and I would really recommend reading the FAQ section of SQS prior to going into the AWS exam.
So let's talk about what SQS is. This entire lecture is theoretical. We're going to look at different examples, but it can be quite wordy, so just see if you can follow me. So Amazon SQS is a web service that gives you access to a message queue that can be used to store messages while waiting for a computer to process them. So if we have an example of a web application, maybe you upload an image file to this web application, and then what that web application will do is it will alert the SQS that a user has uploaded an image file and that a job needs to be executed on it. So it will store that message on the SQS system. You'll then have potentially some application servers that will queue that SQS system, and it will say, oh wow, look, I've got a new job that's just come in, a user's uploaded an image. It will then, those application services might then access that image, which would be stored in, say, an S3 bucket, and would do a task on them, like let's say applying a watermark, for example. Once that has been done, the application servers will update that queue and then remove that message from the queue. So it's basically a way of decoupling your environment, or loosely coupling your environment, so that if you lost that web server, that message is still up in the queue and the application server can still go through and run it. Or for another example is if an application server was lost while it was trying to do a watermark of that image, other application servers could then basically go on and do that task, and we'll look at how that's possible a little bit later on. So Amazon SQS is a distributed queue system that enables web service applications and reliably queue messages that one component in the application generates to be consumed by another component. So that was my example of a web server generating a message that an application server needs to go in and do something inside an S3 bucket. A queue is a temporary repository for messages that are awaiting processing. Using Amazon SQS, you can decouple components of an application so they run independently, with Amazon SQS easing message management between components. Any component of a distributed application can store messages in a fail-safe queue. Messages can contain up to 256 kilobytes of text in any format. Now remember that number, because that comes up time and time and again in the exam. How large can your SQSs be? It's 256 KB. Any component can later retrieve the messages programmatically using the Amazon SQS API. The queue acts as a buffer between the component producing and saving the data, so think of the web services, and the component receiving the data for processing, this would be your application services. This means that the queue resolves issues that arise if the producer is producing work faster than the consumer can process it, or if the producer or consumer are only intermittently connected to the network. So they're basically talking about either auto-scaling there, or talking about failover. So we'll cover both scenarios in a couple of slides. Amazon SQS ensures delivery of each message at least once and supports multiple readers and writers interacting with the same queue. A single queue can be used simultaneously by many distributed application components, with no need for those components to coordinate with each other to share the queue. So it's a great way of scaling out your applications. Amazon SQS is engineered to always be available and deliver messages. One of the resulting trade-offs is that SQS does not guarantee first-in, first-out delivery of messages. For many distributed applications, each message can stand on its own, and as long as all messages are delivered, the order is not important. If your system requires that order be preserved, you can place sequencing information in each message so that you can reorder the messages when the queue returns them. And so this is the example I was talking about earlier, and do remember that first in, first out bit, because it is an exam question, but we've got a slide on all the different exam tips that's coming up. So to illustrate, suppose you have a large number of image files to encode. In an Amazon SQS worker queue, you can create an Amazon SQS message for each file specifying the command and the location of the file in Amazon S3. A pool of Amazon EC2 instances running the needed image processing software then do the following. So basically they're going to asynchronously pull task messages from the queue. So they're going to go in there and pull the messages from the queue. And notice I say the word pull versus push. That's also an exam question. SQS always pulls messages. The message queue is never pushed out. You've got EC2 instances constantly polling the queue, trying to pull data down, and that's a really important thing because it differentiates itself from something like simple notification services, which we'll cover off in another lecture. So it's basically it's polling the messages from the queue, then retrieves the file name of the image. It then processes the conversion, so it might apply a watermark. It then writes the image back to S3. It then writes a task complete message to another queue, and then it deletes the original task message, and then checks for more messages in the worker queue. Okay, so let's look at this diagrammatically. So basically component 1, we'll call component 1 our web server. It sent a message to the queue, and there's a visibility timeout clock as to how long that message is going to be visible in the queue. Now component 2, that would be our application server. It retrieves the message from the queue, and the visibility timeout period starts. So it's important to remember the visibility timeout period only starts when the application server has picked up the message, and that's how Amazon guarantee that the message will be delivered at least once. So component 2 then basically processes that message. So this is our application server. It is now writing a watermark to that image, and then once it's completed, it will delete it from the queue during the visibility timeout period. Now if something happens and that visibility timeout clock expires, let's say our application server goes offline and it doesn't get a chance to do the watermark for that web application, that's fine. That message will still stay in the queue. It won't be deleted, and then another application server will poll that queue. It will see that message has expired, that the visibility clock has timed out, and it will assume that there's been a failure somewhere, and it will then pull that message in and then start its own encoding on it. So it's important to remember it's only when it's deleted from the messages, from the message queue, that's when it's finished, that's when it's complete. SQS can also do auto scaling, so you can configure auto scaling groups to, if we looked at our auto scaling example where we set thresholds, so if you've hit 85% CPU utilization, you can add additional servers. We can also configure auto scaling so that if the queue is getting beyond a certain size, we'll start spinning up more application servers to deal with that. So maybe you've created a new meme and it's gone viral. You posted it to Reddit or something, and someone's picked up a completely a new meme, and suddenly everyone is just flooding your website, wanting to produce that meme with all kinds of different, different sayings on it. So what your application servers will do through auto scaling is they'll see that that queue is growing rapidly fast, and you can set at what point you want to auto scale, but then your auto scaling groups can come in and basically spin up multiple application servers depending on how you set it to then reduce the size of that queue and bring it down, and then you can have auto scaling to once that queue has died down to then start terminating instances. So it's completely flexible, which is why using auto scaling with SQS is so powerful, and it's basically some of the backbones of some of the biggest websites out there, like Netflix, like Reddit, like any of these meme websites where you're encoding images. This is exactly how they structure it. So you've got SQS working in conjunction with auto scaling. So some exam tips for you. It does not offer first in, first out. You've got a visibility timeout window of 12 hours by default. SQS is engineered to provide at least once delivery of all messages in its queue, although most of the time its message will be delivered to your application exactly once. You should design your system so that processing a message more than once does not create any errors or consistencies, so that's really down to your developers. 256K message sizing is now available. Originally they were 64 kilobit, so the billing is still based on the old message sizes, so you're billed at 64 KB chunks, so you get 4 chunks per message size effectively now. Okay, we'll just go through the pricing then. So your first 1 million Amazon SQS requests per month are free. It's 50 cents per 1 million Amazon SQS requests per month thereafter. And a single request can have from 1 to 10 messages or up to a maximum payload of 256 kilobytes. And the final piece is that each 64 kilobyte chunk of a payload is billed as one request. So even though you might be making just a single API call for a 256 kilobyte payload, that's actually going to be billed as 4 requests, because 256 divided by 64 is 4 times. So even though you're making the one request, you're still going to be billed on 4 requests, because it's just basically an old system whereby it used to be 64 kilobyte chunks. Okay, so that really covers off SQS. You just really need to know, and it does mention it in the exam blueprint. It talks about how you can decouple your infrastructure. Anytime you see the word decouple, straight away just think SQS. That's what they're looking for. Remember the size of the payload, so it's 256 kilobyte payload, but it comes in, the billing's done in 64 kilobit chunks.
It's not first in, first out.
It guarantees that your messages will be delivered at least once, and that's pretty much it. Oh, and you can apply auto scaling to SQS. So if you have any questions, please let me know. If you do the exam and you see something else comes up that we haven't covered, please let us know what that is, and I'll update the course accordingly. And if you've got time, please move on to the next lecture. Thank you.